Hey, it's Mr. Smith. In this video, we're going to be looking at percent. We'll also look at a few applications of percent. So let's go ahead and get started. So a percent is a number out of 100. For example, 23% means 23 out of 100 or 23 hundredths. In fact, the word percent means hundredths or per hundred. So each of the following are equal. 24% is equal to 24 hundredths. Remember, percent is a number out of 100. We could write this as 24 times 100th. That would be 24 hundredths. And we can write 100th in decimal form. And when we multiply, we get 0.24 or 24 hundredths. So really what that means, you can see that if we want to go from percent to decimal, keep in mind the decimal's right here. It's understood to be there. 24.0 is what we have. So we would go 2 to the left, drop the percent symbol, and that would be the decimal form. Or if we move the decimal 2 to the right in decimal form, we get 24 and then add the percent. That's how we would go from decimal to percent. Now, before we get into some conversions, going back and forth, let's just look at a couple of pictures to just make sure we have a good understanding of percent. So in this case, the square is the whole, and it's been divided into 100. Each of these are 10. And so you can see this is a picture of 30%. 30% of this big square is shaded, or 30 out of 100 of the squares, or 30 out of 100, well, 30 hundredths of the square. And this is 30 hundredths or 3/10. So 96%, that means we have 96 hundredths of the square, and you can write 96 hundredths in decimal form. So here you have 45 out of the 100 squares are shaded. So of course that means we have 45% of the square shaded, and we can also write this in decimal form as 0.45. All right, so let's go on to writing a percent as a decimal. We've already talked about how we do it, so that's what it's telling you here. So we're basically going to take our decimal and go 2 to the left, and so here we're at 0.79, and we drop the percent symbol. Here, let's see, 1, 2, we'll have 0.057. Why don't you go ahead and do the other 3, stop the video, and then you can see the solution. All right. So I want to mention one thing that I talked about when I did my decimal presentation or video. We talked about how this is a good visual to help you remember when you're working with percents, decimals, and fractions. So again, the number 1 represents the whole, and here we're halfway. This represents a half, and that's also either 5/10 or 50%. Of course, 0 is equivalent to 0%, and 1 is considered 100% or 100% of the whole. So if you look at the number, well, 325%, you can see that's going to be bigger than the number 1. So the decimal's here, so when you go 2 to the left, you get 3.25, and so you do see that this number is greater than 1. So again, this picture is good to keep in mind when you're doing these kinds of problems or conversions. So be careful here. This is actually less than 1%, so it's very small. Sometimes students go the wrong way and they change this to somehow like 25 or something like that. So all we're doing is going to the left. We're expecting a very small number. We get 0.025 to the right of the decimal. That would be 25 10,000ths. All right, on letter E, you kind of had to remember, well, first of all, what 3/4 is, and we can change that to a decimal, and then it'll be similar to the one we just did. So 3/4, if you divide 3 by 4, that's 0.75, and that's percent. And so if we move that decimal 2 to the left, we have 0.0075 or 75 10,000ths. All right, let's move on to going the other direction, decimal 2%. So here when I see this, I'm thinking, okay, this is more than 100%. This time we're going to the right, and so we have 275%. Now remember, 1 was 100%. In fact, 2 is 200%. And so you can see this is even more than that. So here we're going to move our decimal 2 to the right. We get 22.4%. So I would encourage you to do the other 3, stop the video, and then check your work. All right, so let's see how you did. Let's move this one over. You get 5.8%. Here we're going to have 4.15%. And here we need to put in a 0, and we're going to get 10%. All right, so you actually know everything you need to know to do problem 4, and I did tell you how to do it. So again, stop the video and then check your answer. All right, so let's see how you did. So 3 divided 5 is 0.6. Again, I'm going to need to put a 0 in because I'm going to move that decimal 2 to the right. This is 60%. Now this shouldn't be a surprise to us because this fraction is more than a half, which here's a half, 0.5, so it should be something a little bit more than that, and sure enough it's 60%. Now 13 divided by 40, you should get 325 thousandths. We'll move that decimal 2 to the right, we get 32.5%. Now notice this would be less than 0.5. Now to compare them, you'd want to put a couple zeros in. So we know that 0.5 or 5/10 is here, and that's 50%. And notice this number's smaller than that, and we did get a number less than 50%, so, or a percent less than 50%. So again, I hope this is making sense, because it's always better if you can make sense out of what you're doing, especially with fractions and percents and decimals. All right, 3/8. If you divide that, you get 0.375 or 375 thousandths. And we'll move that decimal 2 to the right, and we get 37.5%. All right, so that's the first side of my handout here. Let's go ahead and move to the back and talk about the percent equation. All right, so the most important thing I want to say here is I don't really care how you do percent problems. You could also use proportions, and there's a few different ways that people do it. I'm going to use the percent equation or equations, partially because in this course we're going to be doing a lot of beginning algebra, and so basically we're using algebra here. But I also think it's perhaps my favorite method anyway. So you can use other methods, but this is the one that we'll use, and it's certainly the one I prefer. Now when you talk about percents, like let's say you bought something for $50 and there's an 8% sales tax. So your sales tax would be 8% of 50. In fact, this is the most common type of percent problem we have. We write the 8% as a decimal, and then we multiply times 50. It turns out that the word of indicates multiplication. An example of that would also be with fractions, like if this was a half of 50, we know half of 50 is 25. But you could also multiply 1/2 times 50, and you get 25 as well. So when you see of, think times. So this is our common form of a percent equation. 25% of 40 is 10. So this is very typical. Now when we translate this, 25% of means times, or indicates we're going to multiply. 40 is, now is indicates equal. and 10. And so this is the most common form of percents. When we do percents, I call it the percent equation. Basically what we have is the percent times the whole equals the part. The whole always follows the word of. So that makes it pretty easy. So in this case, the whole is 40 and the part is 10. And it makes sense that the part would be smaller. Now, the only time that's not true is when our percent is more than 100%. 100% of 40 would be 40. If you had 200% of 40, that would actually be 80. So generally speaking, because our percents are usually less than 100%, the part's going to be smaller than the whole. But just keep in mind that if that percent goes over 100%, then it reverses. All right, so let's go ahead and look at the three versions. There's three parts here, right? So basically I can give you any of the two parts and you should be able to find the third. So really you just end up translating these expressions and then you can solve the equation. So there's three examples here. So what is, that's our x. So what, that's x, is equals 40%, we'll write that as 0.40 of, we're going to multiply, times 2. And so this is the equation if I let x equal what? Which is really the part. Because remember, 2 is the whole since it follows the word of, and so the number we're looking for is the part. And again, this is the most common way that we find percents. Really all we're doing is finding 40% of 2, and that's going to give us the part. So in this case, you get 8/10. Now here, what percent, that's what I don't know, we're going to call that x. Of means times. 136, that's the whole, is or equals 17. So notice we were given the whole and the part here, and we're finding the percent. Now we usually write equations like this, as follows: 136x equals 17. We normally put the number first. To get x by itself, we do the opposite of multiplying by 136. We divide by 136. So these cancel, you're left with 1x, or x is 17 over 136. Now when you do that, you get 0.125, but remember we're looking for a percent, and so I move that decimal 2 to the right and add the percent symbol. We get 12.5%. Last one, we have 20.4 is or equals 24%. We'll write that as 0.24 of what number? There's our x, and notice it's the whole here. And so here we are going to want to divide by 0.24 on both sides. And when you do that, you'll get 85. Now, in this case, they actually gave us the part, and we found the whole. And it was bigger, which is what we expect when the percent is less than 100%. All right, so now it's your turn. Go ahead and see if you can translate each of these three problems on number 5, and then I'll put up the answers so you can check yourself. All right, let's see how you did. Let's see. All right, so find 32% of 180. Now when we do this, we're basically finding the part because we know whatever follows of is the whole. So we're really looking for the part. It's 0.32 times 180. There's not really an equation to solve in this form. You get 57.6, and we got a number that's smaller than the whole, which is what we would expect here, because again, our percent is less than 100%. Here, what percent, that's my x, of, we're going to multiply, 75 times 75 is or equals 15. And so we get 75x is equal to 15. I divided both sides by 75 to get a 1x, or x by itself. When you divide here, you get 0.2, which we would want to write as a percent. It's 20%. Now I do want to mention here that what you do have is the part divided by the whole. And so a lot of times for me, I just write it as a fraction, and it's 15 over 75, which is what we ended with, and you end up with the same answer. So I would certainly say if you see that, do that, but you can always use the equation to do it. All right, last one. 45% of what number? Notice that's going to be the whole because it follows the word of. So 0.45 of means times. What number, that's what we're calling x, is or equals 9. So when we solve this, we get x is 20. And that's the whole, so it should be bigger than the part, which is 9. All right, so now we're ready to go ahead and do some application problems. So I would encourage you to try to do these. These are all things, when you deal with money, these are the kinds of things you should understand and be able to work with. Let's see what you can do and then watch the video. All right, so let's see how you did. Let's see. I just put something away I needed. All right, so a computer that has a regular price of $872 is discounted 30%. So in other words, it's 30% off. What's the amount of the discount? Well, we need to find 30% of 872. So we'll do 0.3 or 0.30 times 872. Notice what we're really finding here is the part or the discount. And when you multiply that out, you get 261. So if you're saving 30%, that's about a third. 33 1/3% is a third, so it's not quite a third. So that sounds about right. That's a little less than a third of 872. But that's our discounted amount. That's not what we're going to pay. The discounted price is what it was, the original price, minus our discount. And when you subtract those numbers, you get 610.40. So that's $610.40. So certainly that's a nice deal, better than paying $872. Now I do want to point something out here. You could actually do this problem, or this second part, in one step. Well, we already had to find the discount, so it really wasn't a big deal here. But if I had just said, what's the discounted price, can you think about how you could find that in one step? See, if it's discounted 30%, that means you're paying 70% of the regular price. And so that's another way that you could get the 610.40. Hopefully that makes some sense. Number 7, Susan spends 15% of her yearly salary, that's what we're going to end up looking for, on educational expenses. So 15% of the salary she makes for a whole year on educational expenses. If she spends $2,700 on educational expenses, then what is her annual salary? So we're looking for the annual salary. Now, is that the part or is that the whole? Well, the part she spends on education is just part, so this would be the whole. She makes a salary for the whole year, and she spends part of that on educational expenses, 15%, and that amount happens to be $2,700. Now, a lot of times, students will just take 15% of whatever number they see, and in this case, that would be wrong, because it's 15% of her annual salary, which we're calling X, is or equals $2,700. That's the part. Her yearly salary is the whole. So this would be 0.15x equals 2,700. Notice it's 15% of some bigger number. Her annual salary is equal to this 2,700, the part she spends on education. We'll divide both sides by 0.15, and we get x is equal to $18,000. Now that makes sense because we would expect the amount that she pays for educational expenses to be less. It's a lot less, right? 15%, that sounds about right. All right, so if you haven't already tried 8, I would encourage you to try it again and then watch the video. All right, so what is the tax on the software? So Manuel purchased some software for $45.75. So the tax, well, it's 8% of this price of $45.75. What we're really finding is the tax, or the part. Notice the $45.75 follows the word of, so that's my whole. And so we're just going to multiply 0.08 times 45.75, and you should get 366. So that's the tax. Now the cost, including tax, will be the $45.75, the price of the item, plus the tax. And when you add that up, you should get $49.41. Now again, I would ask you the same question I asked you before. If I had just asked you the cost including the tax, and you didn't do this step, you can do that in one step. How would you do that? Think about that. All right, well, you're paying 100% of the price, plus another 8% of the price, because it's always 8% of whatever the cost of the item is. And so you're really paying 108% of the price. So that's 1.08 times x, which in this case is 45.75. So that would be another way to do the problem. The way we did it was just fine, but hopefully this makes some sense. All right, that's it for this video.